Okay, so this is the first three things, and I think let's solve QAO, or how do you pronounce your name, Jesus Christ? QIAO. Okay, please. Oh, looks like no response. Okay, well, Srigaya 3.
Hello.
Hi there, finally. Okay, it's yours. All right, so let's solve this ECG.
Okay. Um, it is starting off like it looks like an irregular um
Okay, all right. So basically, based on the rhythmicity, it is irregular. Okay, go on.
um uh
But you do see this mostly rhythmic. However, you do see a part
that
that
comes
makes a rhythmic.
the arrhythmic, yes.
Yes, can you point this one? What could be?
What that could be?
Yes. Why is it a rhythmic?
I'm so sorry. I don't know right now.
Well, so you haven't studied enough. So
Yeah.
that basically you can see that these beats come earlier and it looks like it's a ventricle beat. So
And
that's a ventricle premature beat. Okay, that's a ventricular premature beat. Okay.
okay.
So, but mostly it's rhythmic, but we do see a ventricular premature beat. So in this case, you can say that this is a mostly rhythmic ECG that interrupted by some ventricular
Premature.
premature beat. Okay, good. Go on. Now let's focus on the normal uh, QRSs.
Mm-hmm. Um,
First of all, you have to determine what could be the rate.
okay. It looks like it's 75.
No, a little bit faster, because if you do see it, mostly you have three square between the QRS complexes, so the rate is around 100. So you can see it is tachycardic. Okay.
Mm-hmm.
Because that bit that you do have this premature bit, okay, you should determine whether it's compensated or not. How can we determine whether this is a compensated or not? Very simple one. You have to take this interval, all right? This
Yeah.
interval.
Okay.
This interval involves a short and a longer one. This longer is called a compensatory pause, and this is a coupling time. Now, basically, you want to see whether this distance is twice as much as this one. Let's see how many squares we have. One, two, three, four, five, six, and a little bit longer than six, but not too much because here you have a little bit longer. So I would say that this is compensated if you compare to this distance. All right.
Yeah,
So it
yeah.
looks like that's a compensated. And you know that mostly the ventricular premature beat compensated. Okay. Every supraventricular one is undercompensated, but the ventricular one is compensated. Okay, let's move on. The next one, you should determine whether we do have a sinus written or not. Okay, so we should find some P waves, yes?
Mhm.
And officially, the P wave should be the larger one based on number two or AVR. But there is almost no P wave. I cannot see any P wave right here. So this way you should go to the chest leads. Okay, let's look at the chest leads. In
Okay.
V1, we see nothing. V2, well, maybe this one can be.
Okay.
In V3, 3, V4, very nicely, you can see in V4 or V5, for example. And I would say that that could be a sinus rhythm because this is rhythmic, all right? Because this is rhythmic. If you had arrhythmia in this complete arrhythmia, you could say that that's atrial fibrillation, but this is not because that's rhythmic.
Okay.
And all right, so I would say that the sinus one, but the P is, or they place the electrode in the wrong place, or maybe the patient is too fat. That's another possibility, that is obese. And
Yes.
this is why the voltage or the changes of the P doesn't look like. This is not a P wave, that's a T wave, what we have here. That's a T wave, okay? That's a T. Okay, so let's move on. We accept that that's possible at a P. Now, if you decide that's a P, you should measure the PR interval, and that's about less than zero point 0.2, so that's normal. Okay, fine. Go on. Let's look at the QRS complex. Is it narrow or wide?
It's narrow.
Okay, it's narrow. The next one, you should determine the axis.
Okay. Um, so in the first lead, it's I would say negative.
A little bit negative, all right? So I would say that maybe 1 millimeter is negative, all right? So it meaning,
It's a right deviation.
okay, immediately you get the right deviation. AVF is a positive, is okay, but it's meaning that you are somewhere more than 90 degrees, so you are on the right side.
Yeah.
And you should look at AVR, but AVR is negative, so it's meaning you are between 120 and 90. It still can be normal because we see that the pathological right deviation is over 100. So I
Mhm.
would say maybe this is only a right deviation. Okay,
Okay.
only
Okay.
a right deviation. Okay, next one,
Next one.
pathological Q wave. Can you see pathological Q wave?
Pathological Q wave. I think there's no pathological Q wave.
Well, in 1, 2, 3, AVF, AVL, AVR doesn't count. But look at in lead V1, we could see it. Okay.
Ah, okay,
But
yeah.
normally it can occur. That's a QS complex. However, you do have the same QS complex in V2 and V3. Okay.
And this is not normal or
It's not normal because you should have a progression of the R. Okay,
yeah.
but there's no progression, so you don't see that the R is getting bigger and bigger. It has a very deep negative QS complex. So you should have but nothing else. There is no ST elevation or no T inversion. So it can be an old, okay, can be an old anterior MI, but that's an old one, okay?
Okay.
That's an old one. All right. Moving on, okay, the next one that you should specify, hypertrophy. Okay,
Okay.
now I'm helping you to figure out where is the top, okay, where is the top of the R wave, for example, in V5. This
Okay.
is the size. It
Oh,
meaning there's
there's hypertrophy.
28 or so.
Okay.
So
So this is too big, bigger than 0.25.
okay, very good. And because you do see the very large R wave on the left side and deep S wave in on the right side, that can be a,
Uh, Left ventricular hypertrophy.
yes, left ventricular hypertrophy. Exactly.
Okay.
All right. So this is a left ventricular hypertrophy. Okay.
Oh, thank you for your help.
Good.
Thank you.
Okay. Next one, Utano.
Hello.
Okay. Get closer a little bit to the microphone. Okay, and I give you, all right. Well, this about the same. Okay, wait a minute, I getting you a different one. Okay, everything is left ventricular hypertrophy. Hey, yes, that would be fine. Yes. Okay, it's yours.
Um, so it's rhythmic
Mm-hmm.
and it's a sinus rhythm.
Hmm?
Is it a sinus rhythm? Like if there's a P wave, it's a
Yeah,
sinus
but
rhythm.
first let's
Oh,
determine the heart rate. Okay, so that's
sure.
the rhythmic one. Okay, the heart rate is,
Like 100.
yeah, a little bit more than 100, so that's tachycardic. Okay, go on.
Um,
P wave, now the P wave comes.
uh, um, it would be sinus rhythm because there's P waves.
Okay, because you do see very nice P wave that coming regularly, positive in 2 and negative in AVR, and it's rhythmic. Okay, go on.
Um,
Next one, PR interval. Okay, look at the
uh,
PR interval. This is less than zero point 0.2, so that's normal. Okay,
uh,
so there is
maybe
no AV block. Good. Let's go to the QRS complex. Is it wide or narrow?
they are narrow.
Good. Okay.
Um,
Axis.
and the axis in the first lead it's uh positive,
Mm-hmm.
and on ABF it's negative. Or it's
Lead number 2 is negative. It means that this is
um right.
no. One
Left.
positive. It meaning you are on the left side.
Okay.
So this is an extreme left deviation. Okay, extreme left deviation is less than minus 30 degrees. So this is between, because AVR is negative, okay, this is
Yeah.
negative. You can say that this is between minus 60 and minus 30. So somewhere here. But this
Okay.
is still means that we do have an extreme left deviation, right?
Okay.
Now, what can cause extreme left deviation?
Um, I'm not sure.
You should collect this information. First of all, the first thing that we have to think immediately, if the QRS is narrow, the left anterior hemiblock. Okay, the left anterior hemiblock, that will cause an extreme left deviation. Next one, if you do have a pathological Q wave, for example, in on the inferior leads, that can cause again extreme left deviation. WPW syndrome can cause extreme left deviation, left bundle branch block, but in that case, the QRS should be wide. That can cause extreme left deviation. And another one, the left ventricular hypertrophy, very rare, but it can cause extreme left deviation. Now, out of this one, because there is no sign of any hypertrophy, left ventricular hypertrophy, because if you look at the V5, V6, or lead number 1 AVR, this is not too tall, and as is not too deep, so that's and not a left ventricular hypertrophy. So out of this, the QRS is not wide, the PR is normal, and there is no pathological Q wave because you do have initial R wave in lead number 3 or AVF. So that has to be a left anterior hemiblock. Okay?
So because it doesn't, we can't see any other pathological stuff
Situation,
on.
this is why you are ruling out, because one thing,
Okay.
those things that I mentioned, that can see, you can see other sign. If you do see pathological Q wave in an inferior lead, yes, immediately you can say that this is due to inferior MI. If you do see a very tall R wave on the left side, that you can see that's the left ventricular hypertrophy. If the QRS is wide and you do see the sign of left bundle branch block, again, that you can explain it. If
Okay.
not, only the deviation and QRS is narrow, you have to say that this is a left anterior hemiblock. Okay?
Okay.
All right. Let's see the next one. Okay, Victoria.
Yes.
I'm getting you a nice ECG. Yes, I have to. Wow. Wow. Hmm. Okay. I think. Yeah, that could be. Okay. Listening.
Yeah. So I wouldn't say it's rhythmic,
Okay.
since it's yeah, we have like some waves that are like not coming every like regularly.
But what
And
is this one? So we do have, if you are looking at only this part of the ECG, that's
yeah,
rhythmic. This rhythmicity interrupted by this bit.
yeah, it's a
And this bit comes earlier, okay?
yeah,
So it's meaning that this is a
premature ventricular beat.
correct. Good. Now you can focus on the normal bits, okay?
Yeah. So I'm trying to find the rhythm or the RR.
First of all, that's rhythmic. It's no problem. Or the heart rate. Okay, this is
Yeah,
1, 2, 3, 4. So we do have 4 bucks between 2 R's.
so like 75.
Correct. So we do have a 75 beats per minute. That's normal. Okay,
Yeah,
go on. P wave.
P wave. Um,
Maybe I should enlarge a little bit. Okay.
I wouldn't say that I mean, there's P waves, but not.
It's rhythmic. Okay. Let's see that it
Yeah.
is rhythmic. It's okay. And however, this P wave is bizarre.
Yeah.
Because normally the P wave should be a round shape, simple, nice bumps. And here what you do see, this is what you see, yes?
Yeah.
So what do you think? What can it be?
Um, Something that's abnormal with the atria.
Yes? Huh? What is abnormal in the atrium?
Uh, Maybe the conduction from the SA node to the AV node.
Well, so intraatrial
Yeah.
conduction problem, or the P wave is wide, but we haven't discussed yet, or we're not touching the intraatrial conduction abnormality because we do have some preferential pathways, but usually what we do have, if the P wave is wider one, we're assuming that we do have an atrial hypertrophy. And
Oh yeah.
especially if you do see something, for example, in the left side, this notching of the P wave, and the
Mhm.
duration is longer than 0.1 second, it's meaning that we do have a
Uh, oh
P mitrale or
yeah.
left atrial hypertrophy. Okay?
Oh yeah. Yeah.
Okay. Now, and that is fit into the picture because that's notching. If you do have any notch in the P wave, you can
Mhm.
assume that this P mitrale or we do have a left atrial hypertrophy. Okay. Next one, go for the PR interval. Let's look at the PR interval.
Um,
This is the PR interval.
it's longer than
What does it mean?
that. the conduction, like some kind of block from, I guess, the before, like between the atria and the ventricles contraction, it's longer.
So we
then,
have a conduction abnormality
yeah,
between the atrium and the ventricle. This is
yeah.
called
Uh,
these are the AV blocks.
okay, yeah,
Not?
yeah,
If you're evaluating the connection between the atrium and the ventricle, you are evaluating the conduction through the AV node. Okay. So we do have a what kind of AV block? Every P followed by QRS. However, the PR is longer. So these are first degree AV block. What? Hmm? Am I right?
sorry, my, like the when like the, oh, what's it called? Like the Wi-Fi and everything like just stopped
It's
working.
okay. No, it's rebooted.
Yeah.
It's okay. That's no problem. So if the PR is longer, but every P followed by QRS, this is the first degree AV block. Okay?
Yeah.
Fine. Okay. Let's continue. Now the next one is the QRS complex. Okay. First, you want to see whether the QRS complex is wide or not.
Mm-hmm. The QRS complexes, they might,
They wide.
yeah.
Okay. They wide. You can say that is more than 0.1 second. So this QRS complex is wide. Okay. Now, what does it mean?
Um, that the ventricles are not contracting at the same time. Like it might be like some kind of hypertrophy of,
Okay, well, the hypertrophy can elongate the QRS, but not too much. If you do have a wide QRS, you have to think about, and you especially if you know that this as a supraventricle written, you have to assume that you do have a problem inside the ventricle, so you have intraventricular conduction abnormality,
okay.
meaning you can have right bundle branch block
Yeah.
or left bundle branch block. Now, which one that we have here?
Um,
Which lead that you should look at?
is it V1 on V6?
V1, V6, or lead number one, doesn't matter,
Okay.
because you have to look at the right ventricular leads and the left ventricular leads. That's it.
Okay.
And whenever you do see a wide nudged R wave, the block is there. Where
Yeah.
can you see a wide R wave?
Um, yeah, in lead one and
Okay, and that's the left
yeah,
ventricular leads. So you do have a
left bundle
bundle branch block. Okay.
Yeah.
Okay, good. Axis. We haven't said anything about the axis yet.
Yeah. Um, so I'm gonna look at lead one and AVF. So it's positive in lead one and negative in AVF. So that means it's the left axis deviation.
It's a extreme left axis deviation.
Yeah.
Okay, because first of all, lead number one is positive, so you are on the left side for sure. Okay, this is one. After you should look at AVF, and immediately you said that, uh-oh, we are here, right, in this
Yeah.
quarter. After you have to look at lead number two, because lead number two is perpendicular to, okay, oops, I'm sorry. Okay, this is perpendicular to AVS, so that's minus 30. Okay, and somewhere you are here. And after you should look at AVR because AVR is perpendicular to minus 60, okay? And as you see here, this is 0 in AVR, so your axis is minus 60 degrees, meaning that you do have an extreme left deviation.
Yeah.
But what caused this left axis deviation?
We just went over this.
Yeah, we discussed it, as it's
Yeah.
true.
What was it?
The short-term memory usually is wrong in elderly people.
I know. Like am I? Like a
No, nothing because MI, it's meaning that you have to have a pathological Q wave, and I do not think because we have an initial R here, but it's, well, and another one. If you do have this left bundle branch block is difficult to say it, but left bundle branch block itself can cause extreme left deviation, okay?
yeah.
So if you
Okay.
figure out left bundle branch block, the extreme left deviation can be due to the left bundle branch block. Okay. And
Okay.
another thing, if you do have a left bundle branch block, you can see QS complex on the right side. So that's QS. That's a pathological Q wave. It can explain by left bundle branch block. Okay. And especially you do not see any ST elevation here. So there is no sign of MI. So that's only a left bundle branch block. P mitrale, left bundle branch block, and PVC. So premature ventricular beats. This is what we had. Okay.
Yeah.
Nice ECG. Yeah.
Yeah.
Okay. Now let's see the next one. I think is Zoe.
Good morning.
Hi.
Okay. So right off the bat, I don't think it is rhythmic.
Good. I'm
So
gonna enlarge a little bit for you. Okay. Oops. Yes, it's good. So
if
it's not rhythmic for sure.
okay,
And as you see, you don't need to count right now because it's difficult, especially on your monitor, and you do not have
tachycardia.
it. That's tachycardic for sure. You can see because it's mostly the distance between the two R's is 2 or maybe in 3 or less than 3. So that's tachycardic for sure.
Okay, so then we can try and find the P wave.
Uh-huh.
It's a little bit difficult to differentiate whether there's a P wave, and because it's arrhythmic, I don't think there is.
There is no P wave, yes. If you don't like the guy, you don't need to like the guy.
Okay, so because it is arrhythmic and
Mm-hmm. No P wave?
no P wave, we have atrial fibrillation.
Very good. We do have AFib. Very good. That's very, very good. Okay. So we don't need to talk about the P wave, PR interval. Now we can jump into the QRS complex, whether it's wide or not.
I think it's narrow.
Narrow, okay.
Uh, Sorry, I'm just writing the notes down as we go.
Okay. Write it
Okay,
down.
so we have a narrow QRS.
Mm-hmm.
Then we can look at the axis.
Mm-hmm.
Because if the QRS is narrow, we know that there's no interventricular conduction block.
Mm-hmm.
So lead one is positive, AVF is also positive. So we know that it's a normal axis.
Mm-hmm.
The lead two is, I think, the most positive.
A little bit more positive than this one. And looking at AV lead number 3, it's, well, I think a little bit positive. Okay, a little bit positive. So it's meaning that you do have, let's see, around 40.
Mhm.
Okay. All right, go on.
So next,
Pathological Q wave.
um, mm, I don't think I see any.
No, neither. Okay. Next one, hypertrophy.
So we can look at, hold on. We can look at, so in the P waves, I mean, since
No, there's no P wave. We're
there's no
talking
P
about
wave, so
QRS complex.
it can't be atrial enlargement.
No way.
And so if we look at the R in V5 and V6, it's definitely too large.
Well, let's see. That is not too large because if you do have in V5 more than 25 millimeters, immediately you can say it's hypertrophy. Another criteria, voltage criteria, when you summarize the R wave in V5 or V6, whichever is greater, I think about the same, meaning that's about 10 or 15. Okay, that means about 15. All right. I would say that's about 50 millimeters. And here in V2, we have a deepest one, and that means about 11, minus 11. Okay. So the absolute value plus 11, I think it's not too big. This is about 26. So this is not. Okay. So we do not see any left ventricular hypertrophy. I won't say it.
Okay.
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 Okay. Nothing else. That's it.
Okay. Okay. Thank you.
All right. Okay. Let's move on. Oh, yeah. Little bit. Let's see. I'm going to narrow down. Okay. And we go back to the first one is Sringayat.
Hello.
Oh, hi.
Okay. So starting off again, it's a rhythmic
Okay.
heart ECG, and then there is a P wave. Actually,
Yeah. Well, we do see females, so very nicely. And that's relatively is positively number two, negative in AVR. So that can be a sinus. Okay, I accept it.
okay. Uh, and next was the
Next one, PR or the morphology of the P.
okay, the morphology of the P.
Yeah, this is the duration. You have to look at the duration. It's 0.1. It's okay.
Okay.
Is it tall? It's not taller than 2.5 millimeters, so it's not tall and
Yeah.
not wide. So there is no hypertrophy.
Okay, so it's normal.
Yes.
Okay.
Next one, PR.
Right. So one,
It's
two.
about 0.2, so it's okay.
Okay.
So this is not wider, so we do not have AV block. Oh, we are so lucky. Good.
Okay. Should I talk about the heart rate or?
Yeah, okay. Yes, the heart rate. Okay, 1, 2, 3. Oh, well, a little bit less than 4.
Like 180.
Oh, it's okay. 80 is fine.
Mhm.
It's fine to me.
And now the QRS complex or
Yes.
okay.
Is the QRS is narrow?
Yeah, it's narrow.
Good. Axis.
The axis if lead one is positive. Oh, negative. Lead one is negative. Um, So it's a right deviation
Mm-hmm.
or
AVR is a little bit negative, so it's meaning that it's around 110, okay? So it's about 110. So that's a right deviation, okay?
okay. AQ. There's no pathological Q.
Q wave, okay, we do not see any pathological Q wave, that's fine.
And now looking at our oh in V1
No, and
the R I don't there's no hypertrophy.
is not a left ventricular hypertrophy for sure, because normally this is what you should see in V1, yes?
Yeah.
And instead of this, you see a R wave.
Mhm.
And here in V6, what you see, an RS.
Yeah.
And if you are looking at the RS ratio, okay,
Yeah.
it's
It's
less than 1, yes?
Yeah.
Meaning,
But it's more negative,
meaning,
meaning it's a AV,
no, nothing to do with AV.
right ventricular hemi. No?
Right ventricular hypertrophy.
Oh,
A
okay.
deep S wave in V5, V6, and narrow is not a wide, because if you had this kind of changes in the V6 or V5 on the left side, and in the V1 you do see this kind of shape, what would you say?
And if I saw this, I would be a left ventricular?
Nope.
Mm.
That could be which bundle, branch block?
Oh, the right bundle branch block?
Yes, that could be a right bundle branch block, okay? Because in right bundle branch block, we can see R wave, big R wave
Yeah.
in V1, V2, but but the RS complex in V6, the S should be wide, and especially in lead number 1 as well. And here relatively is narrow, but it can be an incomplete right bundle branch block, but this is a right ventricular hypertrophy, because you do not see that the second part of the QRS complex is widening a little bit. So this is a simple right ventricular hypertrophy.
I just
Okay,
ask because you said that the RS ratio was less than 1.
less than 1 on the left side. Exactly.
How could you tell? How could you tell?
Yeah, very simple. Look at the size of the R and look at the size of the S.
Okay, so it goes more into the negative.
Exactly. That's meaning RS
R.
is less than 1.
Okay. All right. Okay. Thank you.
Okay. All right. The absolute value is not the relative value, it's absolute value. Okay. Let's move to oops. It's okay. It's 12 and 13. Okay, Utano.
Hello.
Hello.
I would say it's rhythmic.
Yes.
And
The heart rate, I can tell you, I am getting close to it. Okay. That meaning we do have 1, 2, 3, and a little bit more than 3. Okay, 3.5. Okay, that's fine. 3.5. What does it mean? The rate is around
80, 70.
Well, 90. Make it 90.
So I
Okay.
don't understand how you're calculating with the number of the boxes in between.
Okay, this is a box. Maybe I get closer, right? And you will see it. Okay. These are 5 millimeters, so this is one box. And I said if we start here, okay, we're starting here, that should be this one. After 1, 2, 3, and a little bit more than 3.
Okay.
And after 300 divided by 3.5.
Okay.
But doesn't matter, because you know that if you have 3, that means, okay, it means 100. If you have 4, it means 75.
Okay.
Okay, so let's estimate it. If it's close to 100, 90
Okay.
or so. If it's closer to the 4, say it 80.
Okay.
Does it matter whether it's 91 or 92 or 92? No, nothing.
Okay.
It doesn't count. Okay, go on.
There is a P wave, so
Oh, yeah, we do have P. Okay, positive in lead number 2, negative in AVR, all right. So that's meaning
So it's coming from the SA node.
very good. Okay. Now let's look at the morphology of the P wave. Okay, I'm getting close a little bit.
It's
Okay. This is not wide, okay? That's narrow. However,
it's tall.
yeah,
See,
it's not this one or
No.
not this.
So
What does it mean?
it's right atrial hypertrophy.
Which atrium has this hypertrophy?
The right.
Exactly. Yes.
Yeah. Is that not it? It's the right atrial hypertrophy.
Right atrial hypertrophy.
Yep. Then the PR interval is normal.
Okay, PR is normal. All right.
QRS is narrow as well. The axis, it's positive in 1 and
okay, and yeah, I little bit wait a minute. Okay, so lead number 1 is about 0. AVF is negative. So what does it mean? AVF is negative means this. Yes.
On the upper quadrant, yes.
Okay. And lead number 1 is equiphasic. It means here or here.
Yes.
And because you are here, that can be around minus 90. And especially if you are looking at AVR, AVR is positive, yes? So that can fit with this minus 90. That's an extreme right or left deviation, yes? An extreme left deviation, but exactly on the borderline. But let's say that's extreme left deviation, okay? Meaning, what can it be? The QRS is narrow or a little bit, okay, that's narrow, but okay, I'm getting close to this lead number 1. Okay, I try to, that's not the best one, but if I want to draw it, okay, that's narrow, okay, the first part is narrow, but the second part a little bit wider, yes?
Yeah.
Okay, but in millimeter, let's see, one, 2, it's not wide, okay, it's not wide. So this is still in a normal range of the QRS complex, okay? However, the pattern that you do see here, especially in V1, look at in V1. Look at in V1. I draw it. Yes?
Yeah.
If I say so, okay. But believe me, that's okay. And this is the and oops. Okay, not that. Oh boy. Okay. So what do you think? What could it be? Anybody?
Is it not a right bundle branch block?
Yeah, that's an incomplete right bundle branch block. Yes.
Would it
Yes.
be a bifascicular? Because
Exactly. And because we do have an extreme left deviation, This meaning that we do have a left posterior, okay, the left posterior hemiblock and a right bundle branch block, okay? And these together is called the bifascicular block. And we do have this right atrial hypertrophy as well.
Is it not a left anterior hemiblock because the
Oh, yes,
axis
I'm
is
sorry. You are right. You are completely right because we do have an extreme left deviation, and that's meaning we do have a left anterior hemiblock. Yes. Yes, you are right. Thank you. Hmm?
Okay.
All right. Okay, let's move on. And Victoria, she
Yeah.
came back.
Yeah,
Wait.
it's like I have like a power outage. I'm like I'm sharing my like my personal hotspot from my phone to my computer. So sometimes they lose connection and then I get kicked out of the meeting.
Yeah. Yes, it's true. You know, when I do have the hotspot and I put my phone on the hotspot, it's usually happening if I plug in. So when I'm charging and using the hotspot, it's disconnecting a lot of times.
Yeah.
I have no idea why.
Yeah, no, it's like the washing machine and the dishwasher and everything and all like the lights in the apartment just went out. So I'm hoping it will come back on.
Yeah, this is not an electric power center. Okay, now let's see. This one is yours.
Yeah.
115.
Um, I would say it's rhythmic, but it's
Mm-hmm.
and also I mean the rhythm is normal, like the interval between the the R distance.
Yeah, it's around 3. A little bit less,
Yeah.
more than 3, so it's close to 100, but it's still normal. Okay.
Yeah. Um,
Do we have
and
P
then
waves? Next one. Yeah.
yeah, yes, or yeah, but it's notched or
Yes, it's notched. Okay, that's good. That's very good. So we do have P wave and comes regularly, so that could be a sinus written.
rhythm.
Okay.
Yeah.
All right. So it's meaning because the P wave is notched that we can have a
Some atrial hypertrophy.
enlargement. Yes, and because it's notched in lead number 2.
It's like which atrium?
Yes, which
Uh,
atrium is bigger?
the right.
The
The
right
right.
one has a tall P,
Okay, so the left one.
the P mitrale. Okay, that's a P
Yeah.
mitrale. Okay,
Yeah.
so all right, so P mitrale. All right, next
Yeah.
one, PR interval. You can see very nicely here the PR interval, but here as well. Okay.
Yeah, it's prolonged. So we have some interstitial
Okay, meaning.
that there's a blockage between the conduction from the atrium to the ventricles.
Okay, so
Bundle branch block.
what? This is AV block. This is not
Oh,
intraventricular block.
yeah.
Okay.
Yeah.
So look.
Yeah. Right. Yeah.
Okay. First of all, when we evaluating the P wave itself, okay, the
Yeah.
regularity of the P wave, okay, this is a regularity or shape, okay. This is one thing.
Yeah.
Shape usually for hypertrophy.
Yeah.
Regularity, you can say that a lot of other things, but impulse formation abnormality, okay, impulse,
Yeah.
or SA block, okay?
Yeah.
If you evaluate the connection between the P and the QRS, this is AV conduction, can be AV block or
Yeah.
pre-excitation, okay?
Yeah.
If you evaluate the QRS, again, with whether it is
It's
wide or not,
yeah, it's wide.
this is bundle branch blocks,
Block.
okay? All right?
Yeah.
Immediately you can think about. Okay, and the size, hypertrophy,
Yeah.
all right? And MI. This is a
Yeah.
Q wave, yes? This is what you can do it. That's it. But this is
Okay.
how you go through the whole system, step by step. Okay?
Yeah.
Good. So PR was longer, but every P followed by QRS, there has to be some kind of AV block. Which one?
Yeah.
Mm,
Like from either it's the left side or the right side.
connection between the atrium and the ventricle, that's a AV block.
Yeah.
Which one? Which AV block? There is no right or left. We have only one, okay? When we are talking about the AV block,
Yeah.
the AV is located here.
Yeah.
It's only one. There is no two. Intraventricularly, we have two bundles. This is why we have two.
Yeah.
You should revise the AV block. Every P followed by QRS, but it's a longer, that's first degree AV block. Okay, period.
Oh, yeah, right. Yeah.
Okay,
Yeah.
next one, we finished the AVs. Okay, an atrium and AVs. In atrium, we first found that's P mitrale. Fine. Next one, first degree AV block. Fine. Next, the QRS. Width of the QRS. How wide the QRS is?
It's wide,
Okay, meaning
meaning that there's some kind of also block from the ventricles, like the signal isn't, they're not contracting.
so we do have an
Yes.
intraventricular conduction block. Okay. Which one? Okay, I'm getting this one a little bit. Opa, that's it. Yes.
Yes. I would say it's a left because in V1 it's
Where can you see the wide R wave? The notched R wave. Where can you see it? V1 or V6?
the notched R wave is in V1.
Yes, so where do you have the block?
Left.
V1 is on the right side, not?
Yeah.
So whenever you have the wide R wave, the block is there. Because this area activated later. So you have a problem on the right side. So this is a right bundle branch block.
Okay.
Okay.
Yeah.
Next one, go for pathological or axis. Yes, we haven't discussed the axis yet.
Yeah.
Yeah.
One is negative because of the
AVF is
AVF is also negative.
And EVR is
Positive.
positive. So again, we are, where are we?
On the, wait, AVF negative and then 1 negative. On the
Somewhere
left.
here. So
Yeah,
we do have an extreme
left
left deviation. Oh, extreme right. I'm sorry. This is not good. Oh, I completely do it in the wrong way. Because lead number 1 is negative.
Negative.
So
Yeah,
we are here.
yeah,
Okay? We are here.
yeah,
Lead number AVF is negative. So we are
yeah,
here.
yeah.
Okay. And AVR, of course, this one. So we do have, it's very rare, but we do have an extreme right deviation for sure. Okay.
Yeah.
All right. What can it be? Especially when we do have a right bundle bench block.
Can it be due to the right bundle branch block or?
This, no, itself, it's one cause. That can be a left posterior hemi block.
Okay.
And that's together again a bifascicular block. Okay.
Yeah.
All right. Next one, we're still inside the QRS complex.
Yeah.
Okay. Look at Q wave. Can we see pathological Q wave?
Mm.
No.
No,
And
it's
especially here, you do see an ST elevation as well. Okay.
yeah.
And here as well. Okay. So we do see Q wave in lead number 2, lead number 3, and AVF. Okay.
Yeah.
And ST elevation. So that's meaning a
MI.
inferior STEMI. Okay.
Yeah.
All right. Now, so, and no other, yeah, we do have a pathological Q wave in V6. In V5, we do see an initial R, see, an initial R here. So maybe I show you, that's the initial R, see, this is initial R.
Yeah.
Okay, so it's meaning that we do have an inferior MI, all right, fine.
Yeah.
Okay, next one, let's look at the size of the R. Let's look at the size of the R.
It's very tall.
Okay,
In
and
the
especially it's very
in the
tall on the right side and deep on the left side. Okay,
yeah. Yeah.
so what can it be?
Is it hypertrophy?
Yeah, can be a right ventricular hypertrophy.
Yeah.
Okay.
I
All right.
have a quick
Good.
question.
Yes.
Because we had a first degree AV block and
Yeah, trifascicular block. Yes.
okay. Thank you.
Thank you. All right. But if you look at this big R wave on the right side, this can be due to right bundle branch block, or because the first R is very, very tall, that can be a posterior MI as well. Especially here, you do see this ST depression. Okay. So because we do have QST elevation, that's an inferior MI for sure. And immediately you have to go, whether we do see or not, any ST depression or tall initial R. So that can be an inferior posterior acute MI as well. Okay. Now let's summarize what we found. Okay, let's summarize what we found. That's a sinus rhythm. We do have P mitrale. We do have first degree AV block. We do have a right bundle branch block. Plus, we do have a left posterior hemiblock. So these together is a trifascicular block. We do see an inferior and posterior MI, but because we do see a tall R's and deep S on the right side, we can have on the left side, we can have a right ventricle hypertrophy as well. But of course, you have to use ultrasound to show that this patient, the heart of the patient is enlarged on the right side. So that's almost everything on this ECG. Yes? Okay, good. Let's look at which one I want to. Wow. Okay. I try to find. Okie dokie.
I also have a quick question.
Yes.
Because you said last week that we could do the midterm today. Is that still possible instead of doing it
So
tomorrow?
far, basically, nobody reached that level.
Okay.
This is why I'm giving you tracings. And if you can solve it, I give you, let's say, an off mark immediately.
I have a question.
Okay. Who is having this question? That's okay. Yes, I know. Okay.
So for the midterm, is there a place where we can find all the tracings to practice from?
Yes, I already send you those links when you can download the tracings and solve those tracings.
But is
But
it
for the midterm, the official midterm, there'll be different tracing.
Oh, so it won't be the same ones that we're practicing.
Nope.
Okay, all right.
Nope. Okay. Let's see. In this tracing goes to Zoe, if I'm right.
Yes. 1 second, let me find it as well. Okay. So looking at rhythmicity, I think it's rhythmic.
Mm-hmm.
So let me write that down. Then looking at the heart rate, it's, I think, a little bit less than 100, maybe around 75.
I would say this is 3.5, so this is more. It's less than 4. Okay, you can see this less than 4, so you can go for 80. That's okay.
Okay.
Yes, because if you are looking at here, for example, this is exactly is matching this line. 1, 2, 3, almost 4. A little bit less than 4. It's meaning faster than 75.
Mm-hmm.
So it's 80. Okay.
Okay. Then looking at the origin of impulse, I can see P waves, and it is positive in lead number 2. And in AVR, it's negative.
Mm-hmm.
So the P waves are present, but to me, they seem elevated,
Mm-hmm.
peaked. And the PR interval also seems to be
Not the PR, the P wave first.
Okay. So the P is peaked.
Okay, you can see that is peaked for sure. All right. The next one, you have to evaluate how wide the P wave.
Um, hmm,
One,
maybe.
2, 3, 4, almost 5, almost 0.2 seconds.
Okay.
So
So we have some kind of atrial enlargement.
exactly. Now, you said so far that we do have, okay, a tall P wave, a tall and wide P wave. Okay, so we said this is one, this is second one, and this is what we have here. So
it's right atrial.
It's a combination of these two
Oh,
without notching.
so both atria are enlarged.
Exactly. So it is a biatrial enlargement. Exactly. So if you do see a peaked wide, you have to assume that both atrium is enlarged. Okay.
So next,
The PR, you already figured out that
it's
wide or elongated. It's meaning
we have some kind of AV block.
What kind of AV block we have when the P wave is followed by QRS, but the PR is wide?
First degree AV block.
Yes, very good.
Okay.
Next one, QRS.
So the QRS is, I think it's narrow.
Yes, okay, narrow, good. Axis.
And the axis, so lead number 1 is, I think, mainly negative. Lead number 1 is negative, AVF is positive, so we have a right axis deviation. And lead number 2 is
positive, but we are not caring about the number 2 because we are on the right side, okay? You care about AVR.
Okay. And AVR is negative. So that means that we have an extreme right deviation.
Well, we have a right deviation. We do not know whether it is extreme or not, but we do have, it's, let's say, more than 90. So we are on the right side. You don't know yet, but you can see that, okay, that's more than 120 or 100 because we have a cut that's, if it's more than 100, we do have an extreme right deviation. If it's less, we have only a right deviation. But based on the ECG, it's very difficult to decide by watching at only the, the QRSs, whether this is, it's 100 or 110 or 95, because the AVR is negative, mostly negative, okay? So it's less than 120 for sure.
Okay. And because the QRS is narrow, I think we have a left posterior hemiblock.
Okay, you can assume, yes, we do have a left posterior hemiblock. I accept it. Okay, good.
So next, we can look at the ST segment.
No, pathological Q wave and size of the R.
Okay. So pathological Q, I don't see any.
No, me either. Okay.
And the size of the R in V4 and V5, also V6, I think it seems quite large.
Yeah, that's if you do see a bigger in V5 than 25 millimeters, and I for sure that is more than 25. So that means that we do have a left ventricle hypertrophy. Okay. All right. Yes.
I also think that if we look at V1 and see the RSR prime, so the right bundle branch block.
Yes, it can be right bundle branch block, but because this is not wide, this is called
I'm not sure.
okay, if it's wider than 0.12 seconds, so I said it's bigger than 0.1. This I said this, okay? So it's meaning complete, okay?
Okay.
If it's not, incomplete.
Okay. So it's an incomplete right bundle branch block?
Exactly, an incomplete right bundle branch block. And okay, so Jesus Christ, a lot of things that we had so far.
So it's trifascicular?
Yeah, we do have a bifascicular block because we found a left You said posterior hemiblock. You assume that we do have a left posterior hemiblock. We do have a right bundle branch block, okay? So far we had this one. It's okay. We do have
First degree AV block.
biatrial
Enlargement.
atrial enlargement, okay? And we do have a first degree AV block.
Mhm.
So immediately
Trifascicular.
trifascicular block, okay? And we had left ventricle hypertrophy.
Mm-hmm.
See? Biatrial, trifascicular, left ventricle hypertrophy. Thanks God we don't have MI.
That would be very complete. I don't know if this patient is alive still, but
Well, he's still alive, it's okay, but he's not in a good shape for sure.
yeah.
Okay, good. All right, let's see another one. Let's see another one. Well, that's an easy peasy one, okay. And I think, yes, that's an easy peasy one. And I think now, yes, Srigaya, how can I pronounce your name? Sri Gayatri?
Yeah, that was really good.
Thank you.
Okay. Um, it's rhythmic.
Mm-hmm.
And I see a P wave,
Mm-hmm.
and the shape of the P wave is in the first lead, it's
Doesn't matter the first lead, you should look at the two.
oh, the second. Sorry. In the second lead, oh, it's not normal. It's really tall.
Yes.
Yeah. Uh, so
So it's not wide because if you are looking at this shape, it's about 2.5 millimeters. So I don't think that is too wide.
it's
But it's tall, so
uh, atrial flutter.
I cannot hear you.
Sorry, I don't know.
Okay, we said tall but narrow, nudged, and we had big, wide, and tall. This is,
All
and this is. Before we had, this is the biatrial one, okay? This is P mitrale, the left one. This is the
pulmonale.
right one, P pulmonale.
Pulmonale. Okay.
All right, so this is a right atrial enlargement, okay? Next one, PR interval.
Our interval, it's I think it's fine. It's
Yes, it's normal. Good, very good. We are happy.
okay.
Good. PR is normal. All right.
QR.
QRS.
Okay. So it's narrow
Narrow. Good. Axis.
axis. So one is like positive,
Yeah.
you can say, or
AVF is positive.
it's positive, so it's a normal axis.
Yeah, which is the biggest one, lead number 2, after lead number 3, and lead number 1. So the axis is between these two. So I would say maybe 80.
Okay.
All right. Pathological Q wave.
Vertical Q wave.
No, no, no. Doesn't count AVR. We do have a little inertia, but alone AVR doesn't count anything. AVF, no. So no. ST elevation?
The elevation. No. Oh, yes.
No.
No.
Where?
No,
Where?
no, there is no.
No. ST depression, well, basically maybe here a little bit, but that's is not so big, but if you do see that ST elevation, that can be some ischemia, but that's all, nothing else. Okay, good. So by summarizing the major problem that we had here, that's a P pulmonale or right atrial enlargement. That's it, period.
Oh, that's it.
That
Okay.
was a simple one. Yes, that's a simple one.
Okay, thank you.
Okay. Right, 100, the next one. Okay, 120. Utano.
Hello.
Hi.
It's rhythmic
Mm-hmm.
and the heart rate is about 80, 90.
Okay, how many square we have? Let's see. 1, 2, 3. Let's shift it 3.5. So it's a little bit, I think it's about closer to 75 or 80, 90, doesn't matter. Okay, good. Go on.
So we've got the P wave as well.
Yeah, we do have P waves.
But they seem
Seems to be.
a little tall.
Yes.
Okay.
So,
Right atrial hypertrophy.
yes. Okay. Okay, good. So we found right atrial hypertrophy so far. Okay, good.
And the P interval, I think it's a bit longer than
Little bit, little bit. I like you a little bit, not too much, a little bit only. Yes, it's enlarged. Okay.
so
Try to forget about this little bit.
okay.
If it's not good, no, it's not good.
So it's
Okay. What does it mean?
a AV block.
Which one?
Um,
Uh,
uh,
every P followed by QRS.
yes.
So,
First AV block, primary.
yes, that's a first degree AV block. Okay. The next diagnosis, what we found. Okay. Good. Go on. QRS complex.
They are narrow.
Narrow. Okay, let's see it. Okay, here it's starting and ending here. That's okay. I will accept this is zero point 0.1 or something like that, but let's go here. Yeah, well, it's a borderline, but I would say that okay, it's I would say especially when you do see this kind of sign, I would go and here, if you look at here, that's wide.
Okay.
So if you do see the QRS is wide in anywhere in the 12 leads, you can see that wide. Okay. And all right, and go on.
So if it's wide, then we look at the disturbance, the
Mm-hmm.
disturbance, and it's higher in V6. Oh, in V1.
Mm-hmm.
So it's in the right
Mm-hmm.
right E right bundle French book.
Yeah.
Okay.
Okay.
Yeah.
Axis.
Uh Axes in the first one it's negative, and in the AVF it's positive. Um right. Deviation.
Mm-hmm.
AV.
Yeah, it's again less than 120, but you can assume that there's the extreme right deviation. So,
So,
so
I'm not sure. Oh,
extreme right deviation, meaning we do have a left posterior hemiblock plus right bundle branch block. That's a bifascicular block. Yes, so far. Plus, we do have a first degree V block. This means a trifascicular block. Yeah, yeah. We do have a right atrial hypertrophy. Okay, go on. Let's see the size of the R.
It's enlarged in V5 and
So,
so it's the left ventricular hypertrophy.
as well.
Yeah.
Okay, pathological Q wave. Nope, nope, nope. Well, in AVL, but it's one a little initial R we can have. I don't think. No, 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 no. Oh, no, am I?
Okay.
That was enough. Yes.
Yeah. I'm not. How would a pathological Q wave look like?
The pathological Q wave has a criteria that should, in those leads where we do see normally Q wave, that should be at least 1 millimeter in wide, and the depth of the Q should be about 1/3 of the R. But I said 1/4. Let's count on 1/4 of the R.
Okay.
Or if you do see Q wave where you should not see Q wave, such as V2, V3, V4.
Okay.
Okay. Let's revise the ECG so you can keep studying. And tomorrow we meet at 8 o'clock or whenever you want to join to the lesson.
Thank you. I wanted to
Okay.
ask a question.
Yes.
Because in the email I saw